In this video, we're going to go over how to take an equation that is not in slope-intercept form and convert it into slope-intercept form, and then, of course, rocking a graph of it. Let's check it out. Convert 3y minus 2x equals 12 and it should say into slope-intercept form. Graph the line to. Okay, so the graphing the line is old school stuff that you already know how to rock, but still, we should be able to do it. So we're going to do both pieces here. So 3y minus 2x equals 12. Now, we actually had a little bit of a preview of this when we solved literal equations earlier in this course. So check out solving literal equations. And if you're taking this as an Algebra 2 course, then you might want to look back in the Algebra 1 course in solving literal equations. That's what we're doing right here. So really what I'm saying is all the components of how to do this problem are pieces that you already know how to do. So we want slope-intercept form, which means I'm going to write down right away the form that I want to get everything into. This is our goal, y equals mx plus b. How do we get this here? Well, it appears we need to get y alone and the x term on the right side. So let's do that. So to get the x term on the right side, I'm going to add 2x to both sides. So I guess here, I'll rewrite the problem again. No big deal. And then we add 2x to both sides. The reason why I know to add 2x to both sides is I have the x term on the right side in my end goal here. So when I add 2x to minus 2x, it cancels, and I'm left with 3y is equal to, and I'm going to do something interesting here. Notice I added 2x horizontally on the right side. It's because these are not like terms, the 12 and the 2x. They won't combine. So addition is commutative, so I could write 2x plus 12. I do that so that the template of what we're aspiring to get this equation to look like reflects in my work here. Now, I need to get y alone. So I'm not really focusing on 2x plus 12. I just want to get y alone. To do that, I'm going to divide both sides by 3 to undo 3 times y. So I divide everything by 3 on both sides. 3 divided by 3 there gives me 1, so y is now alone. And now remember, we can distribute 3, it's like multiplying everything by 1/3 to every term here. So it would be 2/3 x, and then you're essentially doing plus 12/3, or 12 over 3, which is 4. So again, dividing 2 by 3 and 12 by 3 there. Ooh, look where we ended up. We ended up with the slope-intercept form of the equation of a line. So we answered the first part of the problem. Now we're just going to graph that thing. So we remember that when we graph, we start with the y-intercept, which is up. 1, 2, 3, 4. Bam. There's my point right there. And now from there, I'm going to rise 2 and run 3 according to slope. So I will go up 1, 2 over 1, 2, 3. Bam. Then we're going to put another point. Let me solidify that. And up 2, 1, 2 over 1, 2, 3. Awesome, and we'll graph another point to the left here, down 1, 2 over 1, 2, 3. Beautiful. And now let's connect those points as best we can with a line and arrows, and we're done. So it's really a nice review problem of literal equations, right? Solving for one variable in terms of another, my goodness, and slope-intercept form and how to graph it. Love it.